All right, complex numbers, this is the first day of Unit 2. You guys should have worked with complex numbers a little bit in the past couple years, but we're just going to go further into it, all right? So first on vocabulary, the complex number whose square is -1 is the imaginary unit. So that's I equals the square root of -1, and I squared equals -1. Okay, make sure you write that down. Any number of this form where A and B are real numbers is an imaginary number, and B cannot equal 0. So that's like 4 plus 3i, or that could be 5 plus 20i, or so on. It could be any numbers as long as that number right in front of I is not 0, because if it was 0, we wouldn't even have an I. Okay, the set of real numbers and imaginary numbers is the complex numbers. And the number A plus BI is a pure imaginary number, if A equals 0 and B does not equal 0. So if it's BI, so that could be like 6i or 7i or 8i or whatever I, okay? A plane similar to the coordinate plane, but you can plot imaginary numbers on it. Complex numbers is the complex number plane. The distance from the origin on the complex plane is the absolute value of a complex number. So make sure you write this down. The absolute value of A plus BI is the square root of A squared plus B squared. Okay. And then complex conjugates are number pairs of the form A plus BI and A minus BI. So those are conjugates. All right. All right, let's start with some visual vocabulary. So for any positive number A, let's find the square root of -A. So -A is the same thing as -1 times A, which is the same thing as the square root of -1 times the square root of A, and the square root of -1 is I, so that's I square root of A. All right? Then if we fill out this little chart, real numbers are A plus 0i, because 0 means that we don't have I in there, so that's just our normal numbers. Imaginary numbers are A plus BI, where B cannot equal 0. And then pure imaginary numbers are BI, where B cannot equal 0. Okay? So that's like 3i, 4i, 5a. While the imaginary numbers, it's like 4 plus 3i, or 4 minus 3i, or 6 minus 10i, or so on. Okay? Okay, we're going to graph these a little bit later, so I'm not going to do those right now. So let's simplify these radicals using I. Okay, so -12 is the same thing as -1 times 12, right? Which is the same thing as the square root of -1 times the square root of 12. The square root of -1 is I, the square root of 12 stays the same. So now we have to break down that square root of 12. So I'm just going to make a factor tree with this. So 3 times 4 equals 12. 3 can't be broken down any further unless we do 1 times 3, and you don't want to do that because we don't want 1 in here. But 4 can be broken down to 2 times 2, correct? And to take something out of a square root, you have to have 2 of them. We have 2 2's, so I'm going to pull out that 2. I'm left with 2i square roots of 3. All right? Let's look at B. Same thing. -1 times 25 is I square root of 25, because the square root of -1 is I. The square root of 25, if we break that down, is 5 times 5. So I can take out a 5. The square root goes away, so that's just 5i. All right? You can look at C, and it ends up being I squared, so 7. And then I want you to think about this. Explain, or I want you to know why the square root of -64 does not equal negative square root of 64. Okay. So now let's graph these and find the absolute value of the complex numbers. So first, when we graph these, we look at our real axis first, which is the horizontal axis. So if we look at A, it's 2 minus I. So I'm going to go over 2 on my real axis. All right, you see that? And then I'm going to go down 1 because it's minus I, so that's -1. And then that is the point right there. So that's our point A. Okay? And then to find the absolute value of that, 2 minus I, remember the absolute value is A squared, the square root of A squared plus B squared. Okay, so that's going to equal the square root of 2 squared plus -1 squared. Simplify that more. 2 squared is 4, -1 squared is 1. So that's the square root of 5. So the absolute value of that complex number is the square root of 5. Okay? Let's do another example. So let's do B. So it's negative 3 minus 2i. So I'm going to go left 3 on the real axis. Okay? And then I'm going to go down 2, and then that is where that point is. Negative 3 minus 2i is right there. Because the imaginary axis is vertical, the real axis is horizontal. Then I have to find the absolute value of that. A is negative 3, B is negative 2. So that's going to be the square root of negative 3 squared plus negative 2 squared. Negative 3 squared is 9, negative 2 squared is 4, so that's the square root of 9 plus 4, which is the square root of 13. And that's the absolute value of that complex number. All right? You can do those two if you want, and if you have questions on them, come in before or after school and I'll help you with them. All right? So the absolute value, just remember, is the square root of a squared plus b squared. Okay? Sum or difference. Let's go through this. So basically, on the sums, you're still just combining like terms. So this is like when we were adding polynomials. So we're going to have the 7 minus 3, and then, because those are our constants, and then my imaginary numbers, negative 2i plus I, which simplifies down to 4 minus I. Okay? When you subtract, distribute that subtraction sign just like when we were subtracting polynomials. So if we distribute that, we get 1 plus 5i plus negative 3 plus 2i, because I just switched those signs. And then you just combine like terms, so 1 minus 3, and then 5i plus 2i, and you get negative 2 plus 7i. Okay, we're going to skip these. You can do them if you need more practice on them. Just compare this to adding and subtracting polynomials. It's basically the same thing if you just treat I like a variable. Okay, I is just an imaginary number, but you can still just treat it as a variable. Okay, so let's simplify these and write them in standard form. So when we multiply these, when we have two parentheses right next to each other, that means we're multiplying. So we have 7i times 3i. So that's 7 times 3, and then I times I. Okay, which is 21 times I squared. And remember, I squared equals negative 1. So that's 21 times negative 1, which is negative 21. Okay, because remember the square root, or I equals the square root of negative 1. So I squared would equal negative 1. Okay? If we look at B, I'm just going to do this by distribution. So I have the 2 times 4x plus 5i, and I have negative 3i times 4 plus 5i. I said x in the first one, there's not x. Then you just multiply that out, so that's 8 plus 10i minus 12i minus 15i squared. And again, I squared equals negative 1, so I'm just going to replace that, the I squared with negative 1. So that's 8 plus 10i minus 12i plus 15. Then I just go through and combine like terms. You end up with 23 minus 2i. Okay? You can do the same thing with this one, except now I'm going to use the box. Okay? So I have negative 4 and 5i on top, negative 4 and negative 5i on the bottom. Then if you fill in those boxes, negative 4 times negative 4 is 16. 5i times negative 4 is negative 20i. Negative 4 times negative 5i is positive 20i. Then 5i times negative 5i is negative 25i squared. Okay. Negative 20i plus 20i cancels out. I don't know why I didn't just cancel that out. But again, I squared equals negative 1. So I'm going to replace that I squared. So I have 16 minus 20i plus 25. Again, those can cancel out. So you're just left with 41, because 16 plus 25 is 41. Okay? There is a pattern to this. So I equals I. All right? Pretty straightforward. I squared equals negative 1, because the square root of negative 1 equals I, so I squared equals negative 1. I cubed equals negative I, because if you take negative 1, multiply it by I, you get negative I to the 4th equals positive 1, because if you take negative I, multiply that by I, you get negative I squared. I squared is negative 1, so negative times negative 1 is positive 1. Okay? And then I to the 5th is I to the 6th is negative 1, I to the 7th is negative I, I to the 8th is 1. Okay, and it just continues that pattern. Like I to the 9th would be I to the 10th would be -1. I to the 11th would be I to the 12th would be 1. And it just continues in that pattern. Okay? All right. I think this is the last little concept on this one. So find the quotient of each expression and write it in a plus bi form. So we need to get rid of I in the denominator. As mathematicians, we do not like I in the denominator, okay? So if we look at this first one, I'm going to multiply this by a negative for I. It's positive, so I'm going to multiply by a negative. You could also multiply that by a positive, but I'm just going to stick with this negative because then it will make my bottom positive. Okay, you'll see in a second. So if we multiply that out, you get negative 20i minus 8i squared. And then on the bottom, you're left with negative 16i squared. Remember, I squared equals -1, so I'm just going to replace I squared with -1. And I'm left with negative 20i plus 8 over 16. Okay, and this needs to be in the form of a plus bi, so that's 8 minus 20i over 16. Okay, and you can simplify this if you want. You could do 8 over 16 minus 20i over 16, which will simplify down to 1/2 minus 5/4 I. You could just leave it, let me see if this will let me write. You could just leave it in that form right there. I'd be completely fine with that, okay? So now let's look at, let's look at D. Okay, I'm not going to do B or C. Let's look at D. So this is where the complex conjugates come into play. So if we have 5 minus 2i over 3 plus 4i, we need to multiply it by something to get rid of that I in the denominator. We have to multiply by the conjugate. So I'm going to multiply by 3 minus 4i and 3 minus 4i. You just change the sign in the middle. Okay? When you multiply that out, you get 15 minus 20i minus 6i plus 8i squared. And on the bottom, you have 9 minus 12i plus 12i minus 16i squared. Okay, you can use distribution for that, or you can use the box for that, either way. Then I squared equals -1, so I'm just going to replace those with -1. And I also combined my i's here. So negative 20i minus 6i is negative 26i. That's where this came from. Okay, and then these two canceled out right there. All right, so that's what happened to that. So now I have 15 minus 26i plus 8 times -1 over 9 minus 16 times -1, which is 15 minus 26i minus 8 over 9 plus 16, which is 7, because 15 minus 8 is 7, minus 26i over 25. And that's your final answer. You can leave it like that, or you can separate it out. You can do 7 over 25 minus 26 over 25i. I will accept either answer. I really don't care. Okay? Save the other two examples. We'll probably do those in class. Okay, remember to take this quiz. Sorry this was a little bit longer, but I will see you guys in class.